When you are implementing a program and working on a unit of functionality, such as a function or some other units we'll learn later, you often want to test that unit in isolation. So let's say you're implementing a function that has some expected types of arguments you can give it and then return values. And so what you'll do is you'll write that function, you'll start up an interactive REPL, for example, in your terminal. You'll try importing that function and calling it with some arguments and seeing, okay, does this return value match what I expect it to? Or maybe you write a main function in a complete program and you call the function that you're working on and print out its results and look at the output of running a complete program. And that way you can run tests multiple times over without having to do all the typing that you would in the REPL. Well, in this video, we're going to take a look at another way that is more common in industry called unit testing. And unit testing is going to give us the ability to write functions which test other functions. And that sounds a little bit meta, but we'll take a look at exactly how this works. And it turns out it's pretty straightforward. The benefits of unit testing and what we'll see are called unit testing frameworks. And today we'll be looking at the PyTest unit testing framework, a very popular one out in the real world and in industry. Is that it makes it really easy to rerun specific tests and to see why some test is failing. So let's dive right into this with an example to motivate where we're going. I'm going to start a new program in VS Code in my lessons directory and call this, say, sum.py. Right. And let's go ahead and give a docstring here that tells us a little bit about what's going on. So this is an example of testing of test subject. So an example of writing a test subject. And what we mean by test subject is what is it that we're testing? Well, let's say we're writing a simple function that we're pretty confident and comfortable with at this point called sum. Okay. And let's say that sum is a function that takes as a parameter an x's parameter that is a list of floating point values, and it's going to return a floating point value. Okay. So the purpose of this function is we give it a list of floats. It returns us back the sum of those floats by adding them all up. And we'll add a little docstring here, compute the sum of a list. Okay. And let's just make this what we call a dummy or a skeleton function that returns something that we know is nonsensical. All right. Negative 1.0. The reason why we need a return statement here is, notice if I didn't have it and I saved my program, I've got a problem. This program says that it's going to return a float, but actually it doesn't return anything at all. So this isn't a valid function. Well, if we return negative 1.0, that's a float. So the contract or the signature of this function is being adhered to. We can give it a list of floats as a parameter, and it's not going to do anything with that. All it's going to do is return -1. So we know this isn't a correct implementation, but it's at least enough of a function to satisfy its signature such that we can call this function and see what happens. So let's try that really quickly. So I'm going to open up my terminal and begin an interactive Python REPL and say from lessons.sum import sum. Right. And now when I call sum of the list of, say, just an empty list, or let's just do a 1.0, 2.0, 3.0, we see that it's -1, as we expect. If we did this with the empty list, so no items at all, we see that it's -1. And this is one of the ways that we've shown you how you can test a function that you've implemented. This isn't unit testing yet. We're about to get into that. Okay. The problem with this method, as you can see, is notice we had to start a REPL, then we had to import our function, then we had to type this out and remember, well, what should this actually evaluate to? And there's a lot of typing involved. And if you had, let's say, multiple tests, like 10 tests for a given function that you needed to run, it would be very tedious to have to do this every time you made a change to your function, and you'd have to keep track of all the tests you needed to run. So what we're about to learn with unit tests is an improvement on what we're seeing here. So I'm going to go ahead and use the trash can to get rid of this terminal, and we'll come back to VS Code. So now let's go ahead and open up a new file that's where our tests are going to be. Right. And this will be a file named sum test.py. right? And in this test function or file, what we're going to be able to do, and notice this underscore test, this is an important convention we'll come back to, is say tests for the sum function, okay? So just like in the REPL, the first thing we need to do is actually import this function that we had implemented. So from lessons.sum import sum, right? Now notice that we've got an error here. It's telling us that you haven't actually, oops, I have an extra space there. We haven't actually used this function that we've imported, right? That's what it's going to tell us. It was imported, but it was never used. That's okay. We're about to go use it, all right? So let's write our first test function. So def, and this will be test underscore, and that will be important as well. Sum empty, right? And test functions are going to be parameterless functions for now that return none. So they are procedures. And what we're going to do is we're going to make assertions. And an assertion is a common term in computer science for saying we're going to assert something should be true or needs to be true. And if it's not true, then there's something wrong with our program because it should be true based on how we expect this program to behave. And so the way that we write an assertion in Python is we use the assert keyword followed by a Boolean expression. And here's where we're going to actually use our sum function. So we're going to test the sum function by calling it sum of the empty list and assume that it's going to be equal to 0.0, right? So this is our expectation of how sum should work. We give it an empty list. There's no items in it. And we expect it to be 0 as the return value, right? So after sum evaluates, we want this to be 0. Now, I want to point out that I could have had a variable set up. This is just a plain old function. So we could have set up our, let's say x's is a list of float, and it's the empty string, or the empty float, sorry, empty list. And I could sum x's, and same idea, right? Nothing too fancy here. Great. So now if I open up my terminal, we can try running this as a PyTest, right? So I'm actually going to make this full screen here, or close to it. There we go. And run Python m PyTest, all right? So PyTest is a package that was installed as part of your setup process at the very beginning of this course. If for some reason PyTest doesn't run when you issue this command, come work with us, and we're happy to get you going on that. So Python m PyTest, and then here's where things are going to be a little bit different than what you've seen before. We're going to say lessons / right? And so on Windows, this is a /, and on Mac it will be as well. Lessons / and then our test file was sumtest.py, right? So notice this is different from, this is more like what happens when you go to export your project or an exercise, where we're giving what's called a path, which is, this is the directory / and then the full file name, which is different from, when you run Python m lessons.sumtest without the .py. And it's a little bit confusing why you would use one versus the other. The short story is, when we use Python m, this needs to be a Python package name, whereas here we're trying to give a file name specifically. So when I run this, notice that we see that there's a failed test, and this is actually some really great output that we're seeing here. So let's break down what we're seeing. So it says we've got some failures, right? And in our failures, we see that, oh, this is the function we just wrote, this test function. We knew that it was a test because it began with test underscore. And it's trying to tell us this is the line. So notice this little caret here. This caret is telling us this is the line that had a failed assertion on it. So something that we expected to be true, well, didn't ultimately pan out to be true. Well, what was it? Well, this tells us -1.0 equal to 0.0 is the assertion that failed. What's very cool here is notice that this is telling us -1.0, where this value came from, was in calling sum on the empty list. So it's telling you, this term, the left-hand side of the is equal to operator, is what returned or evaluated to -1.0. And so we have a sense, oh, We really expected 0 to be the returned value of calling sum with the empty list, but for some reason, when we called sum with the empty list, it returned -1. Okay, that tells us that we have some work to do. We need to go implement our function correctly. So I'm going to just X out of my terminal for a moment, and let's return back to our sum implementation. Right? And so you notice that it's pretty obvious why this failed. We've got -1.0 as our return value. So we can fix this function, right? We can make this a correct passing function, and we can return 0.0, right? That's what caused this test to fail. So I changed my function implementation to return 0 from sum, and I'm going to try running this again. So I'm pressing up and running that exact same command one more time. And what do you know? I have one passed test in 88 or in 0.08 seconds. So it tested that very quickly. And our work is done, right? No, our work is not done. If we look at the sum implementation, we know that we have more work to do. This may work for the empty list, but it doesn't work for lists that have values in it. So let's try adding another test case, and we'll start to see where the value of unit testing comes from. Okay, so let's say we define a test named test sum, and let's say this is going to be a single item, right? None. So it's a procedure, and I can say assert sum of, let's say, the item 110.0. So it's a list with a single item in it. And again, if we wanted to make it very obvious, I could have said X is a list of floats, that is the list 110.0. Same thing. I didn't need to make this X's variable, but to just convince you that we have all the powers of a function inside of our tests, because they are just functions at the end of the day, that's going to be equal to 110.0, right? So that's what we expect here. Great. Now we've got two tests in our test file, and I'm once again going to open up my terminal. I'm going to leave this one scrolled up to the top. So here's my terminal. I'm going to press up to rerun that exact same command again, and then enter. And what do you know? We have one test that passed. That was our first test, the sum empty. And we have one test that failed. And we can see that the test that failed was the test that has the single item in it, this test case. And we're summing x's, which we expect to be 110, but notice that we get 0 from this summation. So we've got a problem here. Now our function doesn't work for one of the tests that we've written. And that's good, because if it doesn't, then that means that we have more work to do, and we know that there's something wrong with our implementation or the subject that we're testing. Okay, so I'm going to be kind of silly here and do something that's intentionally very strange, that you know is not how we implement a sum. But I just want to prove to you some of this process of writing tests, convincing ourselves that we're actually writing correct tests and our implementation works for those tests. And then thinking critically about whether or not the tests that we're writing actually make sense for the function, and that we're testing all of the edge cases that we expect a function to be able to work with. So, okay, we failed with the empty list, or sorry, we failed with the single item list. So let's add an if statement here. That's if the length of x's is equal to 0.0, we return 0. Else, we return x's index 0, right? And so, of course, we know that this is not a correct implementation of sum, right? This implementation of sum is saying, if you give me an empty list, I'm going to give you 0. If you give me a list that's not empty, I'm going to give you the first item back. And what do you know? We can run our tests one more time. And both of them passed. And it looks like, wow, we've got, both of our tests passed. This must mean that we've got a working sum function. But we can look at this definition, and this is insane. This is not a correct implementation of a sum algorithm. So just because your tests are passing does not mean you have a correct function. Your tests need to actually test the range of functionality that you might expect a function to behave with. And here, 0 items, 1 item, these are good edge cases. There might be lists that have just that. But we also know that we want sum to work when you've got multiple items in it. So let's try adding another test case here. So def test sum mini items, right? And so our test names of the functions that we're writing, as I mentioned, the important thing is that you begin your test function names with test underscore. And these also need to be put in a file that ends with underscore test. These are two conventions of the PyTest framework that we're using that let PyTest know, hey, this is a special test function just by convention of its name. It's not some other function that is just a helper function or some other function that you've written, okay? So how do we work here? So maybe I'll have my x's be a list of floats. That is, say, 1.0, 2.0, and 3.0. And we assert that sum of these x's is going to be 1 plus 2 plus 3, so that's 6.0, right? Okay. So I've added, this third test, and third test is here. Great. So we now have 3 test cases in this test file. Let's try running this program. And we expect this test to fail now, right? Because our implementation was very silly. One of the other things that I might show you this possible, because when you're writing tests for the functions that you're implementing, you often want to be looking at both at the same time. In VS Code, you can take a tab and you can drag it. You'll notice that if I drag this tab to the right-hand side of my screen, it shows that it's taking up the right-hand half of it, or the left-hand side. And you can have both files open at once. So I'm going to make my text a little bit smaller here. And so notice that you can have what we call a split pane, where the left pane can be your tests if you want. The right pane can be your subject and the functions that you're working on. And okay, so what can we do now? Well, let's try running our tests one more time. And I'm going to run that exact same command again. And notice that 2 tests pass, 1 failed. Well, which one failed? We look in our output. We see that here are the failures. This is telling us test sum mini items was the test that failed. And it's telling us the line that failed. Sum of x's was 1.0. And remember, why is it 1.0? Well, remember, we have this naive implementation of sum, or I should say this insane implementation of sum that returned the first item of a non-empty list. So of course, 1 is the first item of the list we were summing. It returned 1. And what's great about this is we can see all this in the output, right? It's telling us this is the assertion that failed specifically, and this is what you got back. 1.0 was the result returned to us from the sum function. We tried to say that we tried to assert that this was equal to 6.0. It's not. So this is why this test failed. And notice that if I wanted to run this set of tests again, boom, it's just so easy versus think about where we're coming from, where you needed to begin a new REPL session, import your function, write function calls, and remember which functions to call. And so if we wanted to do that with 3 tests, it would have taken quite a bit of typing. But because we can write these in a singular file, organized in a specific way, our test cases are written in a file named _test.py, or that end in _test.py. And then each of our test functions is a function that begins with test underscore. Okay, so how do we correct this implementation? Well, let's go ahead and use, I'm going to very quickly update this to reflect what we've seen in the past. So I'm going to keep a variable named total. That's a float and initially 0.0. Maybe I'll have an I that is an integer for my index that is 0. And while I is less than the length of x's, what we will do is increase total by x's at index I. We will increase I by 1, and we will return total. All right. So hopefully by now this sort of pattern of a summation is pretty comfortable and not too hard to follow. We set up a variable to accumulate our sum. We loop through all the items in our x's list. For each item, we're adding the current item to the total, and then we return that total. All right. So this is what we know to be a correct implementation of sum. We try running our tests one more time, and notice, boom, all 3 tests pass, and we're looking pretty good. Okay. Now, with VS Code, there's one other piece of functionality that I want to show you, that if you go to your extensions and you have the Python extensions installed, so here we see that I do have the Python extension installed. I don't have this install button beside of it. So Python, which is from Microsoft, and that's great. And also PyLance is another package we are importing and using in our VS Code. And notice that's installed as well. So when you set up VS Code, you should have installed both the Python plugin for VS Code and the PyLance plugin. If for some reason either of those weren't installed, press that install button. And once you do, we've got this pretty neat functionality that for me, I have to press additional views to see testing, but let me try making this all a little bit smaller. You'll see this little flask or beaker over here that if you hover over it, it says testing. And when you click it, what you should see is if you don't see any output here, try pressing this refresh button. And if your refresh button, if pressing it leads to something saying there were errors collecting tests, and I can give you a demonstration of this. So let me just add some weird character here. So I'm going to delete from right here. I just deleted my colon at the end of my function definition line. So I have a syntax error here. And so if I refresh this, what you'll see is like, oh, there's a PyTest discovery error. And it tells you that you should look at the output and see the Python output to know where the discovery error happened. So we should talk just a moment about this because this is such a common problem. If you open your terminal and you go to the output tab, so normally we're in the terminal tab. You'll want to come back there when you're running PyTest in the command line. You go to your output tab in Python. One of the things that you'll see when we run, so I'm going to run rediscovery, and we see that here's this error, and it tells me that in this particular file, here are these E's. So you look for these E's in the left-hand margin. In my sum.py file, notice it's telling me I've got invalid syntax, and this little caret here is trying to say, oh, you're missing something here. This is where the syntax was wrong, and that's where I had deleted that colon. So I add my colon back. And for you, if there are any other files in your project or in your course workspace that have syntax errors, you're going to see this happen. And you want to go fix those. And we can help you fix syntax errors. So come work with us in office hours if that's the case. But once you've got all your syntax errors gone, if you refresh, you should see, we can look in our workspace and we see in lessons, oh, here's some test. And notice here, there's 3 test cases. And what's pretty fun is this little play button will run these tests for us. So I press play and notice that all 3 tests pass. What if I had accidentally started my total variable? So I'm going to change my sum implementation to make it incorrect for just a moment to say start from -1. And if we do that and I try testing this specific test case, notice that we see that it's failed. Or if I tried running all 3 of these test cases by pressing the play button for this particular file, we see that they failed. And what VS Code is trying to tell us here is very similar to what we saw before. So if I look at this file, we see that we've got these tests that are failing. And if I were to hover over this, it gives us some output that says -1.0 is equal to 0.0. That's the error. Oh, we accidentally created a bug in our implementation. So let's go back and fix that bug. I'm going to make that back to 0.0, save my sum file, and try rerunning my tests again. And boom, they all pass this time, right? What's kind of cool is once this is set up, if you're working on a test, these buttons become clickable. So you can actually rerun a test just by clicking a button beside of it. So if we wanted to add one more test that was to say def test sum mini items 2, again, a bad test name, you should name your tests very specific to what it is that you're testing. And let's say assert sum. And then here, I'm going to use a list literal to give you an example of not having that extra variable that I set up for the other ones. And let's say that we have negative numbers like -1.0, 1.0, and -2.0 and 2.0. So here we expect the sum to be equal to 0, right? So let's make that our assertion is equal to 0.0. Okay. And notice that when I save this file, VS Code is kind of checking in the background once we have this plugin working, and we see this play button here, and boom, I try playing this, and we've got that check. So our function works with all of these tests, and that's pretty great. Again, the testing beaker over here is one way of doing this. Now, I want to emphasize that I actually think that using the terminal and having the terminal open and just running your tests by pressing up and enter is as good, if not a better way, as using VS Code. Sometimes VS Code's plugins can get a little bit out of sync and out of whack, but the terminal way is always going to work well for you. So this is a quick introduction to the idea of unit testing. I want to point out one thing that we like to do when we're thinking about, well, what tests should we write? And I want to annotate my screen here for just a moment to give you some examples of this. When we think about defining a function like sum, the test cases that are probably what we would call the normal use cases are these. All right, so I'm going to label this use cases. When we mean use cases, we mean what are the usual ways or what are the usual cases that someone might use when making use of our function that we're trying to work on. Well, if we're trying to sum up a list of numbers, we probably have more than one number in that list by default. Like we're looking up, adding up all the scores of some games or some of the points of some students on a quiz, things like that, right? So the common case is when you have many values that you're trying to add up to evaluate to a singular value, right? So oftentimes, if you're working on a test, these are what we would think of as like the bread and butter, the most important test cases to be sure that you pass. This is how we expect people to use this. Now, there are other cases that are important too. So these are what we call edge cases, where we probably don't expect to sum up an empty list very often, but we better be sure that we have a correct implementation of our function if you do call this function with an empty list. And so when you're working with functions that take in lists, being sure that your function works with an empty list in the way that you expect is an edge case that you should be careful of. We call it an edge case because it's kind of at a boundary. You can't have less or fewer items than an empty list. And it's sort of on the edge of how we would expect someone to use this function, but it needs to work nonetheless. The single item test case I would also classify as an edge case for the same reason. When you have just one item, there is no real summation that's going on. You're just using that. But our function better work with just a singular item as well. So in terms of strategies for how do you go and write your own test cases for functions that you are implementing, I typically recommend starting with the simplest test cases you can imagine first. Those often wind up being edge cases, and getting those tests passing, and then going back and writing, okay, well, what's the next most complicated test I can pass that gets me closer to how I expect to really want to be able to use this function, and implement that test case, try and make it such that your function fails it, and then improve your function so that it passes it. And we followed that exact same process in working on this sum function today. And that's the process that we encourage you to use when you're implementing your own functions and testing them. And we'll get practice on this in the next set of functions that you implement for you, the next exercise. So this is a quick introduction to unit testing, and it's a really nice way and tool to have in your repertoire to test functions that you're working on without having to jump through all the hoops of retesting those functions in the REPL. Unit tests give us the ability to very quickly rerun tests in a mechanical, automated, and programmatic way. They're very common in industry and are a very powerful tool as you're implementing your own function definitions.